So let's go ahead today and take a look at what some of the special cases for solving inequalities might look like and how we'll end up representing those solutions. In our first example here, we are going to be dealing with a no solution problem. I'll give you the spoiler on that ahead of time. Go ahead and let's follow through the solving process. 2 times 2c is going to be 4c. 2 times the positive 8 makes positive 16, and we're going to continue adding that c that we haven't done anything with. Keep the less than symbol, keep that 9 plus 5c minus 7. Go ahead and combine like terms. On the left, 4c and c makes 5c. Bring down that plus 16. Keep the less than symbol. And on the right, then I notice that a positive 9 and a negative 7 are both constants. We can combine those to make 2, and we'll bring down the plus 5c as well. Get all those variables to one side. If I want to cancel on the right, I'm going to have to subtract 5c away from that positive, and then I'll do the same minus 5c again on the left. So cancels on the right and also happens to cancel on the left. So I'm left with 16 is less than 2. When you take a look at that, ask yourself, is 16 less than 2? If I have $16, do I have less than somebody who only has $2? Well, no, we don't. That is a false statement. So any inequality that you get once your variables have all canceled, if it is false, this clues you in that you have no solution for that problem. Now, how do you represent no solution on a number line? On a number line, I want to put a point or put an arrow over top of the values that make the solution true, that make my inequality work. In this case, there is no solution. There's nothing that's going to work. So you're going to end up with a blank number line. I write this NA not applicable next to it just so that I know I didn't forget about it and skip it by accident, but it is blank because there's nothing on the number line that will work for me. So to go ahead and write this in set builder notation, set builder we know always has curly braces with it. And in this unique case for no solution, we're going to use a different symbol. It looks like a 0 with a line crossed through it. And anytime that you see that, this is referred to as the null set. This means that it's empty. There's nothing that we can use to fill it with. Simple enough then. Interval notation, this is also the special exception to the rule. I'm going to take that null symbol, and that is just my whole interval. It doesn't have the brackets and parentheses for the starts and the stops because, again, there's nothing to start at and nothing to stop at for this no solution. There's no value that's going to work. So if you can remember the interval notation symbol, then you just pop it inside of the curly braces for your set builder notation. If we go ahead then and take a look at the infinite solutions idea, let's solve that inequality. I'm going to have to distribute that positive 5. That'll make a positive 15. And then 5 times the y makes positive 5y. Bring down everything else, the 8y plus 21 greater than or equal to, and the 3y. Combine like terms where we can. So a 3y and a 5y gives me 8y there on the right. Keep that plus 15 with it. And bring down the other side, 8y plus 21, and it's still greater than or equal to. So we got to get all the variables to one side now. I want to cancel on the right here with that minus 8y, and I'll do the same minus 8y on the left. So I canceled on the right just like I wanted. Notice it also coincidentally canceled on the left. So all the variables canceled. We're now left with 21 is greater than or equal to 15. So without any variables, you're asking yourself, is 21 greater than or equal to 15? Well, yes, it is. This is completely a true statement. If your variables cancel and you wind up with something left over here that is true, this is how we know that we have infinite solutions. So how do you represent those infinite solutions on a number line? We're talking about every single number that you can imagine works in this inequality. Every single number that you can imagine is a solution. So you highlight and you shade every value from left to right on that number line. Everything can be used in there. So what does this look like in set builder notation? The set builder we know is going to have those curly braces on it. We're going to introduce the variable. That's letter Y. Put your vertical bar in to say that we're ready to get to the good stuff. Now, we're talking about every single number that you can imagine. This is what we call every number that's part of the reals. So we write Y is an element of, and this is kind of a funky E. It's like you draw a letter C and then put a line in it, and this means it is an element of. And then we talk about the real numbers as part of the real number system, where you draw a capital R with 2 bars in it. So again, this is right saying that Y is an element of the real numbers system. Okay. Any infinite solutions problem that you have is going to have that same looking set builder notation. The only difference will be what variable you use to reference it. I'm using y from my inequality, but infinite solutions always says that it's any number you can think of from the real number system. Now, the interval notation for it starts on the left side of our number line. It's an arrowhead to the left. That says it's going all the way down to negative infinity. And we know curvy infinities always have curvy parentheses. Then follow it up, and what's on the right side? As far to the number line as you can go on the right. Arrowhead to the right. That takes me up to positive infinity. Curvy infinities always get curvy parentheses. Those are the special cases and how we're going to represent their solutions. Have a wonderful day.